Good evening friends. I hope you are following the thermodynamic video lectures thoroughly. Now today our goal is to complete the isothermal process. In the previous classes we completed isochoric process and isobaric process. Now our goal is to learn about the isothermal process. What does it mean by isothermal process? In isothermal process, the temperature of the system must be constant. So this is equal to temperature is equal to constant of the system. So to maintain the temperature of the system at a constant, the system must be have the special essential conditions. Then only it can have the temperature of the system must be maintained at a constant temperature. So what are the essential conditions for the isothermal process? Means there are two main important essential conditions are there to process the system as isothermal process. The first condition is the walls of the system must be perfectly conducting material. That means let me take this is the cylinder. The cylinder walls must be have a perfectly diathermic walls. That means they are perfectly conducting walls. What is the importance of this? What is the use of this condition? Means when the heat energy is having large, the temperature when the heat is supplied to the system, then the heat must be transferred to the surrounding from the system. Then to become the system must be maintained at constant temperature. Once again I am telling, the walls of the system must be a perfectly diathermic wall, that is nothing but the perfectly conducting walls. What is the use of this condition? Means if we supply the heat energy to the system, now heat energy we are supplying to the system, then what will happen? The temperature of the system must be rises to become the same to maintain the system at constant temperature. The system have the provision to supply the heat energy from the system to surrounding, then the walls must be conducting walls only. That case only it will only possible the energy must be transferred from system to surrounding. The condition number 2, the process of compression or expansion should be so slow. What is the importance of this condition? Means so if the process is very slow, that means we are giving the large as much amount of time to transfer the energy from the system to surrounding as well as the surrounding to system. Once again I am repeating, if the process is done in a slow process, that means we are giving the provision to transfer the heat energy from the system to surrounding as well as the surrounding to system. That case only the temperature must be maintained at constant temperature. So there are the two conditions. Condition number 1, the walls must be perfectly conducting. The condition number 2, the process must be very slow process. It may be compression, it may be expansion. So in the isothermal process, what is the equation? What is the equation of state of the thermodynamic system? Means here T is equal to constant. If this process is equal, T is equal to constant, that means the Boyle's law will holds good in this process. So we are having Boyle's law holds good in this process. That means the process can obey the Boyle's law condition. What is the Boyle's law will telling that? So P is inversely proportional to volume of the gas at constant temperature. The pressure of the gas is inversely proportional to volume of the gas at constant temperature. So then I am removing this proportionality proportional. We need to keep a constant here. So that constant we need to evaluate, that is equal to 1 by V. Now sending this V this side, PV is equal to some constant. This is the constant we are having. This is the constant. So what is this constant? Means from the ideal gas equation, PV is equal to nRT. So this constant is equal to nRT. for 1 mole of gas is equal to, then RT will come, this value is equal to RT, where N is equal to 1 mole of gas. This is the ideal, this is the equation of state, that is Boyle's law will holds good, that is the value of the constant value also we are taking. Now let me go to the graphs, for the graphs in isothermal process. Isothermal process. So let me start with the PV graph. PV graph. So PV graph, what is saying? The PV graph relation is equal to P is equal to some constant into 1 by V. That means what is saying that, so the volume will be decreased. If the larger volume is there, then pressure must be very small. If the very small volume is there, the pressure must be very huge. That is, if you take a graph here, so the volume in the x-axis, pressure in the y-axis, then at high pressure the volume must be low. This is the high pressure, volume must be low. At high volume, pressure must be low. This is the value. Then the decreasing of this graph must be like this. This is the shape of the graph. This shape is nothing but it is the rectangular hyperbola. So rectangular hyperbola shape graph is there. So then if you go to the another graph, let me go to the another graph. So the relation in the VT graph. So VT graph means in this our condition is the isothermal condition, then T is equal to constant in our process. Then if the gas is the expanding, that is equal to volume is increasing. So if we take temperature in x-axis, volume in the y-axis, then if the volume is increasing, this is the graph like this. This is the expansion of gas. So the volume is increasing. Then one more graph we can take. If the temperature like this x-axis, volume in the y-axis, if it is compressing means volume must be decreases like this. From it will start from a higher volume to lower volume it will get. So this is the compression of gas graph. So from these two equations what we will get means what is the slope of this graph? What is the slope of graph? Slope of graph in the VT graph in the isothermal process. Slope is equal to, so dy divided by dx, that is equal to here dv divided by dt. Then dv is having some value, but some value is there, divided by dt is equal to 0. Then the slope is equal to infinity. This value is equal to infinity value we are getting. Now let me go to the another one PT graph. We are going to the PT graph. So in the PT graph means as the temperature is equal to constant, then if we take the two graphs, the temperature in the x-axis, pressure in the y-axis, then the pressure is increasing pressure graph. This is the pressure is increasing. So the volume is compressed, the pressure is increasing. So here is the increasing pressure graph. Otherwise we will go to the another one more graph here. So the temperature in x-axis, pressure in y-axis, then the pressure will decrease. This is the decreasing pressure graph. So then what we say means here the increasing pressure and decreasing pressure. What is the slope of these two any graph? Slope of any graph means the change in y value divided by change in x value. Here change in pressure value divided by change in temperature value, that is equal to some value will be there in the pressure value divided by 0, that is equal to some value divided by 0 is equal to infinity value we will get. So in the similar manner we need to find out the pressure of the P and V graph also. Let me go to the slope of the PV graph. So slope of PV graph. slope of the PV graph. Now let me go to the slope of the PV graph. Now once again I am drawing the PV graph here. So this is the pressure and volume. This is the graph shape like this. So we need to find out this slope. So this a tangent which is drawn here, this the slope we need to find out the theta. So this slope we need to find out. So this slope means how we can find out this value. So that value is equal to, now let me take PV is equal to some constant relation there in the isothermal process. Now P is the variable here, volume is the variable here. Now I am differentiating this equation. So differentiating this equation means so I am using the UV method. So d by dt of UV is equal to U dash V plus V dash U. This is the formula we are having. So this is the V, this is the V dash U. This is the formula we are having. So let me take in the similar manner. So P dash is the U dash is nothing but du into V plus dV into U. This is the formula we are having. So that here is the dP into V plus dV into P, that is equal to 0. Then our goal is to find out the slope is equal to opposite side this value dP, adjacent side this value is equal to dV. This value is equal to dV we need to find, that is equal to dP by dV we need to get. So in this equation what we need to get, that is equal to dPV is equal to negative of dVP. So that is equal to dP by dV is equal to dP by dV is equal to minus P by V. So the slope value is equal to minus P by V. This is the very important one we need to use to solve the problems. Now I hope you understand about the slope of the graph. Now let me go to the what is the work done in the isothermal process. So the work done in isothermal process. So in the isothermal process we need to find out the work done. So what is the work done formula? The work done formula W is equal to integral of dW, that is equal to integral of P into dV. This formula is known. But in our case, what is the problem here means in our case PV is equal to some constant is there, that constant is equal to nRT is there. So the P and V are both are available. So we need to convert the P value in terms of V. Now that is equal to P is equal to, with help of these two relations I am taking, P is equal to nRT divided by V we will get. Now substituting above equation, integral of nRT divided by V into dV. Now integrated this equation with limits. So now I am integrating at initial condition volume is equal to Vi, at final condition volume is equal to Vf. Then in this equation n is the number of moles is the constant, R is equal to ideal gas constant, that is also constant, temperature T is equal to, this is the process is the isothermal process, that is also constant. So all terms are taken out, n r T, these are the constant, integral 1 by V into dV. Initial condition is the I, Vi, final condition is the Vf. So you are very familiar with integral of 1 by x into dx is equal to log x with base e. This formula is known for you. So with help of here 1 by v dv is equal to log v will come, that is equal to nRT into log of v. The limits are there, initial value of Vi, final value of Vf. Now with help of this one, once again I am writing last formula nRT into log of v. The limits are there, Vi into Vf. Apply the lower limit first, apply upper limit first, after that we need to apply the lower limit again, log of v. So I am substituting here upper limit, that is equal to Vf minus log of lower limit Vi. I hope you already well familiar with log of A minus log of B is equal to log of A by B. This formula is known. So then with help of this formula, that is equal to nRT into log of V final minus V initial. This is the formula we are getting. This is the work done in isothermal process. One more condition I am taking. So in the in the isothermal process, PV is equal to constant we are having, that is equal to P is equal to some constant divided by V is getting. That means one more formula we can take, just I am interchanging this one. V is equal to some constant divided by P we will get. So with the help of this one, if I am substituting here, V initial is equal to some constant divided by P initial we will get. V final is equal to some constant divided by P final we will get. That means with help of this and this equation, V final divided by V initial is equal to P initial divided by P final we will get. So P initial divided by P final we will get. So with help of this equation, with help of this derivation, so then this formula can be written as so that is equal to nRT log of Vf. Instead of Vf, what we can write? P initial divided by P final we will get. So that is equal to Vf divided by Vi can be written as Pi divided by Pf. This is equal to one more formula for the work done in the isothermal process. Now let me go to the what happened in the isothermal process. What is the first law of thermodynamic? So the first law of thermodynamic in isothermal process. First law of thermodynamic in isothermal process. In isothermal process, what will happen? Now I am recalling the first law of thermodynamic. What is that? dq is equal to du plus dw. So you already well familiar with dq is equal to ncv into delta T. But in our process is the temperature is equal to constant, that is equal to dt is equal to 0. Then du is equal to 0 will come because of dt is equal to 0. Then first law of thermodynamic will be converted as what will happen? The first law of thermodynamic. So dq is equal to 0 plus dw, that is equal to dq is equal to dw. So we already known. So one more conclusions we are getting this one. So first of all I am writing the equation. We already known the what is the work done in isothermal process is equal to nRT into log of V final divided by V initial, that is equal to one more formula is there, the nRT into log of P initial divided by P final is there. Now with help of this equation we are going to conclude some of the conclusions. One more time I am writing dq is equal to dw. So please concentrate. If heat energy is supplied to the system, that is named as the positive dq will come. What does that mean? Heat is supplied to the system. Supplied to the system. Then that is equal to dw must be positive. Then dw must be positive. That means what will happen? Work is done by the system. So work must be done by the system. So what does that mean? If we are supplying the heat energy to the system, then a work must be done by the system because of positive work done will come. So negative dq means the heat is ejected from the system, then negative dw will come, work is done on the system. So that means if we are performing a work on the system, heat will be ejected from the system. If a work is done by the system, heat must be supplied to the system. That is the very important conclusion in the isothermal process. I hope we are covered each and every part in the isothermal process. We are covered the graphs, we are done the work done in the isothermal process, we are covered the conditions, what are the conclusions in the isothermal process, and also we are covered the what are the condition to maintain a isothermal thermodynamic process. So I hope you enjoyed this lecture. If you are feeling that this lecture is very useful for your academics, now I am requesting you, please subscribe our channel and also share this video to your friends. Thank you for your supporting. Thank you.